Hi everyone. In today's class, we'll start with a new topic, carboxylic acids. And we know carboxylic acids are very important group of organic compounds, right? And they are known by this functional group, COOH, right? This is your functional group for carboxylic acids. If I little expand it, this is how it looks like, right? And before carboxylic acids, we are done with aldehydes and ketones and alcohols also, right? We are done with these two topics. Now, if you look at carboxylic acid group, it is made up of, this is your alcohol group, right? And the name is, let me write down the name here, this is your, we call this functional group, which is for carboxylic acid, as carboxyl group. Right, this is your carboxyl group, and here this is your hydroxyl group, right, which represents alcohols, right. This is basically your hydroxyl group, right, and this one is your carbonyl group. Carbonyl group, right? And if you look at this word, the carb of carbonyl is taken from this, the carb of carboxyl is taken from carbonyl, and this OXYL, oxyl, is taken from hydroxyl. Since carboxyl group is made from carbonyl group and hydroxyl group, so its name is also derived from carbonyl group and hydroxyl group, right? So what we have done is, to name the carboxylic group, we have taken carb from carbonyl group and OXYL from hydroxyl group, right? So we got carboxyl group. Now, one important thing is, you may think that since this group is made up of hydroxyl group and carbonyl group, right, so it will show the chemical reactions of both aldehydes and ketones, or the chemical reactions of carbonyl group and chemical reactions of alcohols, that is hydroxyl group, but it is not so, right? This carbonyl group will show different chemical properties, different chemical reactions. It's not that it will show the chemical reactions of both carbonyl groups, carbonyl compounds and your alcohols, right? So this group will show different chemical reactions than carbonyl compounds, carbonyl and hydroxyl compounds. We know that carbonyl compounds are aldehydes and ketones, right, and hydroxyl compounds are alcohol. So it will show different chemical reactions and chemical properties from alcohols and carbonyl compounds. Carbonyl compounds we know are aldehydes and ketones, right? Now, simple carboxylic acids are obtained, right, by adding H, methyl, or your C6H5 benzyl group, right? So if I add H here, what I will get is we know this is formic acid, right? And if I add CH3 here, this will be acetic acid, right? And if I add C6H5, this will become your benzoic acid, right? Should know the name of these simple carboxylic acids. Now, coming on to the classification of carboxylic acids, right? And then we'll do the nomenclature, how to name these carboxylic acids, right? Coming on to classification first, right? Now we know two things. By this conversation, we know two things, that carboxylic acids or all carboxylic acids contain carboxylic group, right? and all carboxylic acids are attached to a group. This carboxylic acid, this carboxyl group is attached to a group, right, which can be hydrogen, a methyl, or your benzene ring, right, benzyl. So carboxylic acids are classified. These are classified based on two things. First is group, which can be like hydrogen, like we have done here, methyl or C6H5 attached to your carboxyl group. Second classification is based on the number of carboxylic group, right? Based on the number of carboxylic groups, we have mono, di and tricarboxylic acids. Mono, di and tricarboxylic acids, right? So these are two broad classifications of carboxylic acids. First we'll look at what group is attached, right? Suppose we have hydrogen or methyl group attached, we call these acids as aliphatic carboxylic acids, right? So based on this, we have, if hydrogen or methyl is attached, what we have is these acids, CH3COOH or formic acid, right? These are aliphatic carboxylic acids. We call these as aliphatic carboxylic acids. Or if your benzene ring is attached to this carboxylic group, right, like this. This is your carboxylic group. To this, if I attach benzene, what I get, since it has benzene ring, so we call it as aromatic carboxylic group acids, right? So this is one type of classification which is based on the group attached to the carboxylic group. Here you have, in acetic acid, you have alkyl group. So any acid that has alkyl group are aliphatic carboxylic acids. So any acid that has benzene ring, C6H5, benzyl or benzene ring, is your aromatic carboxylic acid, right? Now the second classification is based on the number of carboxylic acid groups, right? Number of this was the first. Okay, one more thing that you need to look at, this aliphatic carboxylic acids. These aliphatic acids are also called as fatty acids, right? One thing we should know this, that you will hear that people will be calling aliphatic carboxylic acids as fatty acids. Why we call these as fatty acids? Because the natural fats, right, that are there, these natural fats contain esters, right? And actually these acids, these higher carboxylic acids, when we say higher carboxylic acids, we mean carboxylic acids containing 12 to 18 carbon atoms, right? Carboxylic acids containing 12 to 18 carbon atoms are termed as fatty acids. The reason is because these carboxylic acids, right, in the form of esters are present in natural fats, right? So when you hydrolyze natural fats, or when you hydrolyze natural fats, these esters get hydrolyzed to corresponding carboxylic acids containing 12 to 18 carbon atoms, right? So these are obtained by hydrolysis of fats. That is why we call these as fatty acids, right? So why we call these as fatty acids? Because these are present in natural fats as esters, right? And if you hydrolyze these esters, these will give you when you hydrolyze these natural fats, right? So basically you are hydrolyzing fats only, right? And these fats contain these esters, right? So when you are hydrolyzing fats, these esters that are present in fats will get hydrolyzed to carboxylic acids, right? Containing 12 to 18 carbonatols, right? That is why these carboxylic acids that are obtained by hydrolysis of fats are termed as fatty acids. That is why we call these as fatty acids, right? I hope this is clear, right? This point. Now let's look into the classification based on the number of carboxylic groups attached, right? You have this CH3COOH, right? CH3CH2COOH, right? HCOOH, right? This is your ethanoic acid, this is your propanoic acid, this is your formic acid. All these contains one carbon atom. Sorry, all these contains one carboxylic acid group, right? All these contain, you can see, one carboxylic acid group. So we call these as monocarboxylic acids. Monocarboxylic acids. And these monocarboxylic acids are only these fatty acids. Now suppose if I take an acid, and one more thing, this acid also contains one carboxylic acid group, so this is also categorized as monocarboxylic acid. Now suppose this is the acid, right, or this is the acid, or this is the acid. All these acids you can easily see contain two carboxylic acids group, right? So these are classified as dicarboxylic acids. Di means two, right? Mono means one. So these are classified as dicarboxylic acids. Dicarboxylic acids. Di means two. That means two carboxylic acids group, right? Similarly we have other acids that can contain three carbon atoms, right? This is your succinic acid, right? If you want to know what's the name of the acid, right? If you want to know the name, this is your oxalic acid, this is your malonic acid, this is your succinic acid, right? And all these are dicarboxylic acids. Di means two, because these contains two carboxylic acid groups, right? Now let's look at these acids. CH2COOH, CHCOOH, CH2COOH. Now you have three carboxylic acid groups in this acid, right? Now there is another acid which is CH2COOH, CCOOH, right? You have OH, instead of H you have OH here, and CH2COOH, right? The name of this acid is citric acid. The one that contains OH is your citric acid, right? This is your citric acid, right? And this is your glycolic acid. I'm sorry, this is your contains tricarbolic acid. This is your tricarbolic acid, right? Now if you look at these two acids, it contains three carboxylic groups. It contains three carboxylic groups, right? So these are your tricarboxylic acids because it contains three carboxylic groups, right? So this is classification based on the number of carboxylic groups, right? If it contains one, it is monocarboxylic acid because mono means one. If it contains two carboxylic groups, it is termed as dicarboxylic acid. Di means two, right? If it contains 3 carboxylic acids, it's a tricarboxylic acids, right? Example is tricarbolic acid and citric acid, right? Just to try to remember the names of the acids as well. And the first classification was based on the group attached to the carboxylic group, right? Which classifies them as aliphatic acids and aromatic acids. And now we will look into the naming. Okay, one more example. Here this was monocarboxylic acids. Monocarboxylic acid. And if I take from aromatic acids, this is your dicarboxylic acid, right? Similarly, if I take this acid, this is your a different isomer, right? And if we take, suppose this acid, this is your orthoisomer, this is your phthalic acid, right? And this is your isophthalic acid, this is your terephthalic acid. These all are dicarboxylic acid, right, of aromatic acids. I hope this classification is clear based on 2 things. First is the group attached, the second is the number of carboxylic acids. Right, now we'll look into the naming, how to name these carboxylic acids. Right, I'll just rub this on. Naming carboxylic acids. Naming, as we have been naming other organic compounds, we name these organic compounds based on common system and IUPAC system, right? So naming is common system, when we talk about common system, the name of some acids is derived from the source, right? The name is taken from the source from which these acids are derived, right? For example, if you know HCOH is your formic acid. Formic acid. Why we call this as formic acid? If you look from the common system of naming, because this acid was used to be obtained from distillation of red ants. Distillation of red ants, right? And this ants, in Latin word formica means ants, right? That is why we call this as formic acid, because it is obtained from formica, right? Formica is ants, right? That is why we call this as formic acid. Similarly, if you remember CH3COOH, most of us know about this acid. This is acetic acid, right? This is named as acetic acid. So from where this word acetic came, this acetic acid was originally obtained from acetum, right? This was obtained from acetum, so this is named as acetic acid, and acetum is vinegar, right? So acetic acid is obtained from vinegar. Vinegar in Latin is acetum. This is in Latin language. Similarly, formica is for ants in Latin language. So this is named as your acetic. Acetic is taken from the word acetum, which in Latin means vinegar. Similarly, you have CH3, CH2, CH2COOH. This is your butyric acid. Butyric acid. Butyric acid means this butrym. Butrym means butter, right? Butrym in Latin means butter. Since this acid was obtained from butter, so we call it as butyric acid. This is how the common system of naming goes, based on the source from which the acid is obtained, right? Now, in the common system, the position, if you just look at some acids, the position of substituents, right, which would be present on the chain, is indicated by Greek letters. Suppose you have some acid, say the COOH it contains, it has a carbon chain, right? So in the common system, you may have substituent and at these carbon atoms. So these substituents are prefixed by, firstly these carbon atoms are alpha, beta and gamma, right? So alpha, where you will name these substituents as alpha substituent, beta substituent and gamma substituent, right? So as you, in the common system, these carbons are designated as alpha, beta, gamma, right? That is carbon next to carboxylic carbon, right? This is your carboxylic group. So carbon next to carbons next to carboxylic carbon are alpha, beta, gamma in the common system, right? So if I take an example of acid, right, if I take this acid CH3CHOH COOH, how will you name it? Based on this system, this would be alpha, this would be beta, right? So this is 1, 2, 3. The longest chain contains 3 carbon atoms. So this is your right? Now it has COOH group. So this is your OIC, propanoic acid, right? At alpha carbon atom, it has OH group. So this is your the substituents are prefixed. The name of the substituent is put before the name of the acid. That is in prefix. Prefix is before the name and suffix is after the name. So the name of this substituent is prefixed. That is, it is alpha hydroxy propanoic acid, right? This is how you will name it alpha alpha. This is all one word, alpha hydroxy propanoic acid, right? Just understand how will you name the substituents, right? Now we have another system of naming, which is your IUPAC system, right? Like we have been doing from the beginning. IUPAC system, it's simple. In the carboxylic acid, we will identify the longest chain that contains your carboxylic acid group, right? Carboxyl group. Then we will number the carbon atoms, giving number 1 to the carboxylic carbon, right? Then based on this Arabic numerals, you will prefix your substituents, like we have done prefixed here based on the common system, right? Let's take one example. Suppose this is the acid. We will take first simple one, CH3CH2COOH. It contains 1, 2, 3, 4. This is your, it contains 4, so the name of the alkane is BUT AN, right? E of alkane, now it contains 1, 2, 3, 4. Now parent alkane would be butane because it contains 4 carbon atoms. Now E of alkane would be replaced by OIC, butanoic acid, right? Now let's take a different example. If I take CH3 this 1, 2, 3, right? It contains 1, 2, 3. This is the longest chain that contains your carboxyl group, right? Longest chain of 3 carbon atoms that contains carboxyl group. So this would be propane, right? Propane is the parent alkane, so E would be replaced with OIC, propanoic acid, right? And the substituent would be prefixed based giving the Arabic numeral. We will not be giving alpha, beta, gamma like in common system, right? So this is your 2-methyl propanoic acid, right? Similarly, if we have CH3 CH3 COOH, this is your longest chain, 1, 2, 3, right? So this is again propanoic propanoic acid, right? You have 2 methyl groups at carbon 2. So this is 2,2-dimethyl. 2,2-dimethyl propanoic acid. Right? I hope this is clear. Now, let's quickly look into the nomenclature. Right? How nomenclature, right, further. So now we know how to name it based on common system and your IUPAC system. Right? Now we'll look at all these were monocarboxylic acids. Let's name the dicarboxylic acids. Nomenclature of dicarboxylic acids. We have done this in classification. So it contains 2 carbon atoms. So parent is parent alkane that contains okay, one thing I forgot to tell you, that when I said IUPAC system, IUPAC naming, in IUPAC naming you name these as alkanoic acid. Right? Alkanoic acid, in which E of alkane, right? You will remove E of alkane and add OIC. So this will become alkanoic acid. Right? Now similarly, in case of dicarboxylic acids, the IUPAC name is alkane dioic acid. Right? So this is the parent. This is how you will name dicarboxylic acids, alkane dioic acid. Right? In place of right, dioic is, that means it contains 2 carboxylic acid groups. Right? So this contains 2 carbon atoms. 2 means ethane dioic acid. This is how you will name it. Right? I hope this is simple. Now if suppose this is the acid CH2COOH, it contains 1, 2, 3, 4 carbon atoms. Total you have 4 carbon atoms, right? And your parent carbon would be 1, 2, 3, 4. It contains 4 carbon atoms, so it would be butane. It contains 2 carbon atoms. Sorry, it contains 2 carboxylic acid groups. So butane dioic acid, right? Like here, it would be butane dioic acid. Or you can also name it in a different way, which is your butane. You can tell the position of this COH group. Butane 1,4. One of the COH group has number 1, the other has 4. Butane 1,4 dioic acid. Right? This is how you will name this acid. Now let's quickly look at aromatic acids. Aromatic acids, if this is your aromatic acid, right, you have substituent this. This substituent would again be prefixed, right? The substituent would be prefixed, like 1, 2, 3. So it would be 3-nitro. The parent acid is benzoic acid, right? Benzoic acid. 3-nitro-benzoic acid. Right? I hope this is clear. Let's look at one more example. If you have COOH, OH, 1, 2, 3, 4. So this would be 4-hydroxybenzoic acid. 4-hydroxybenzoic acid. Right? I hope this is clear. Thanks.